I learned so much about you, about the ins and outs of your souls. Wonderful. So now, after we get to know the human part of each other, let's jump back into AI. And what we will do is look a little bit deeper on this AI. What we want to get today is a little bit understanding neural networks. The question also came up yesterday, why are neural networks important and why didn't I talk about it yesterday? Yesterday was more of the entire pipeline, and now I would like to show it quickly to you because we're basically using the same basic technology to do super different things. And why is that possible? And hopefully, with what I show you in the next couple of minutes, this will become a little bit more visible. So, AI chatbots, very much again. So, of course, we all know ChatGPT, but there's also a thing called Eliza. Eliza was the first chatbot that people actually thought they were talking to a real human. It was called Eliza, and it was developed already in 1966. And this Eliza chatbot was built as a therapeutic support staff or whatever. So you would tell the system your problems, and it would come up with questions to challenge that. How do you feel? How is the day-to-day? What does it make you feel and stuff like this? And it did it well enough that people thought they were talking to a real human. And it also did it well enough that people thought it was really good and really nice. And it sparked an AI hype already in 1966. And like today, people were thinking that the autonomous AI is just around the corner, which was not true then and is not true now. But then also very cool that this thing, type of thing is around already for very long. Another thing that we already know how to pass the Turing test, for example, so the test where you cannot differentiate if you're talking to a human or a machine, is just taking the last word and make a question out of it. So I don't know, you talk to me, the last word, and take a question out of this question mark, and I'm yes, you can do this and that. And so there are, it basically was exploiting that. It was exploiting very simple rules of conversation to make it appear that that it could talk to you and that it could make you think and introspect. So 1966, now jump forward. We talked about this at length. I don't have to tell you about ChatGPT. It's now basically the thing that a lot of us use every day. I do, and some of you do as well, and we all should do this in general. So what changed between 1966 and I think 60 years later, 2022? Was that Eliza was completely rule-based. So it was basically a huge list of if statements and said, if this, then do that, if else this, then do that. And it was basically a huge bunch of code. So the developer had to think of every potential situation that could come up and just hard-code it into this Eliza bot, which of course is a lot of work. But on the other hand, he could control perfectly what would happen if you put in some data. On the other hand, we were also talking this yesterday a little bit after the lecture. This is 100% deterministic. So whenever you ask the same question, you will get out the same result. And if you understand what it is looking for inside the question and put the same phrase in the same position, then you will always get the same answer. On the other hand, what we have now, of course, is based on neural networks. Neural networks is basically what we talked about yesterday. You have an input. This input is transformed in some way through a social network, and by some magic it creates an output. The great strength about this is that we don't care anymore how the input looks like, because we can use every number of input parameters and just throw it through the neural network. So we don't have to account for every situation, because the neural network has come up with some way of dealing with every situation. Is it the right situation or not is the hard part to make this right, but it will never reject anything because it does not have a answer to that, does never have a good response to that. That's also what you see, of course, when you ask ChatGPT an impossible question that's impossible to answer. It will never say, I don't know, but it will also try to provide you with some kind of answer because that's what it's trained to do. Okay, so you know I have quite a lot to do. We were also talking that I'm doing the tech for the ice cream place, and I brought you a game, a side-scrolling game with this fantastic character. And why did I do that? Because we want, now that I've built this game, I don't really want to play it, but I want a machine to play it. And the machine I want to play it is basically, look what happens in front of you. So we have a small input window. This, by the way, could be a real use case. Then you would not have a one-dimensional input window, but a two-dimensional probably for a kind of side-scrolling game. And I basically want it to, depending what you see here, do something. And I make it a little bit more granular, so you have some things. So there are 5 areas where you should check, is there some collision? For example, there's a floor, there would be collision. Then there's nothing, so there's no collision. Then do something. And the outputs, of course, can be on a controller. So I'm basically trying to put from the visual input that I get to the output on the controller, which could be left, right, up, down, or jump. Wonderful. So in this case, we could already see, okay, I see there is a floor, perfect, there's no hole in the floor, and the rest is completely free. So obviously, we as a player would put right and say, okay, now move to the right, please. And when we have a bad guy appearing, then of course, what would we do? We would still go right, but we know that we can't just run into that guy, but we need to jump over him. So in that case, we would need to say right and jump. So how can we solve that? We can solve that classically first, basically what Eliza does with a large list of statements. So we say the input is just this long thing of 1 is true, 2 is false. We just have to come up with a definition, and O is the output. And now and we have all the rules, if one of these is true, then we define the output, we run through all these statements, and then we go to the right. In this case. This works perfectly if we know everything that can happen. For this kind of video game, it's probably super simple, and we can probably write a deterministic tool that will get very much the perfect score in that, probably will never die, and probably has accounted for all the situations that can come up in this kind of game. And when we see a bad guy, we run through all the calculation again, or through this one calculation again, and we now have 1 is not, so 1 is, actually I wrote it wrong, I'm so sorry, but 1 is covered and 2 is now also covered, but 3 and 5 are open, so try to jump through 3 to 5 and try to jump over that bad guy. So now in this case, we just say, okay, the output is right and jump. We can also do the exact same thing with a neural network. And the neural network that I have here is written like this. There is not a right position, first of all, for neural networks, and there's also no right and wrong, how it looks like, how many nodes it has, and what its parameters are. But basically what this does, the way I put it here, is it also tries, so the green lines would be it triggers, the input triggers a neuron. Red or green means is the neuron triggered? And then basically from this trigger, again, the green lines out of the neurons say what do we append to our output parameter. In this case, for example, a red green would trigger this very low neutron, and the triggered neutron here could be inversing, so say, okay, this is negative. I don't want to, for example, here go into the second neutron, I don't want you to jump. So when 1 is covered, please don't jump. And the second neuron is looking for 2, 3, 4, and 5. All of them are green, so they trigger the second neuron. And when they are green, then it says go right. Does it make sense so far? Wonderful. So we already see a lot of problems with that. We also see a lot of opportunities with that, so we can make this more complex and account for more characters. For example, we could go in a second dimension and be more granular. On the other hand, there are things now that can happen that, for example, don't give me a good answer, that I have 1 covered, 3 covered, and 5 covered, which would probably not trigger the second neuron, probably also not trigger the third neuron, and not trigger the neuron on that side, so the guy would just stand there. So we would do a thing then which is called evolution. We would do a thing called learning, reinforcement learning, which we will cover in a later class, but this is basically the ups and downs of that, so we don't have to explicitly write the rules ourselves. It can learn it by itself, and when it's good enough, when we just give it enough data from enough runs, for example, it can play better than any human can. In the simple case of a 2D side-scrolling game, it's probably still easier to write it hard code, but in a complex case, like us trying to produce human language, then this might be the way to go. Some terms that we need to know. First of all, these nodes that I put now below each other are called a layer. So we looked yesterday at GPT-2, which has, I think, 10 layers. I'm not super sure anymore. But those layers are basically the calculations that happen between input and output. There can be several layers because you might need to work with intermediary results. For example, this second layer that sees if I'm jumping or not probably needs some information from the ground and from above the ground. So for example, here we need 2 layers. We also had the term explainable AI yesterday in a conversation. This AI would be super explainable because we can see exactly what it does, but it does not need to be that it's very explainable. Usually, in particular when you do machine learning, the machine comes up with the layers itself and with the nodes itself, and the machine doesn't really care if the layers make sense in our human understanding, that we, for example, try to jump or we don't try to jump. It just needs to make sense for the machine, and it needs to make mathematical sense, which of course might not be very explainable and not very human readable. A second thing that we have, the one thing here is called a neuron. That's just something to brag about when you go to work tomorrow and you say, you ask how many neurons do we have in our network, then you can brag about that you know what this is. It's basically a calculation machine that it does. There in between the input and output are so-called hidden layers because the user is not aware of that and does not need to know of them. We have convolution. That's happening basically that we take a lot of information and try to reduce it to a lower level of information. And we have potential weights. For example, many neurons might shoot on the same output, let's say, for example, jump, then the upper neuron might be more important than the lower neuron. Thus, we could give it a higher weight and say, if the lower neuron says don't jump and the upper neuron says jump, then it has a very high probability that jump would be the right thing because the upper neuron just gets a higher weight. So it's just a linear function. That is what is called a weight. And biases would be in this calculation. That is what's happened in the neuron. So we have a kind of matrix. We have the input vector that is multiplied by that. And we can always add some, you know that from a Kurvendiskussion, we could always add a C, or we could also add other parameters to that. Those other parameters that we might want to add so the calculation results get better for us are called biases. And those is what you probably heard, that those neural networks have weights and biases. That's exactly what's being meant. The biases are ingrained in the neurons, and the weights are in the channels between the neurons, or the neurons and the outputs. All right. So which one is better? It depends very much on what you want to do. The great thing about neural networks, again, is you can get to insanely complicated problems with rather simple solution because, again, the machine calculates it itself. For example, when this camera has to track me, we could now either try to hard code this and, okay, look for 2 eyes, look for a mouth or something like this. It's a little bit hard because it can be differently lit, people have different eyes, it could wear glasses and stuff like that. And the other thing I could do is I just throw a bunch of people in front of this camera and give it a starting neural network and say, try to come up with a solution yourself. It's very calculation heavy, it's probably not very efficient, but it does the trick. And this is what this camera does. The Xbox Kinetic camera did the same thing as well. So nobody at Microsoft knew why Kinect was working, but it just was working. So we can be very versatile with this solution and solve problems that would be way too complicated for a human to solve. For example, image recognition. For example, creating text output and so many other things that do help. On the other hand, the downsides that come with that is exactly the explainability. So we don't know exactly what it does, and particularly in security critical scenarios, we should know that there is no bug that could give it, if we give it a wrong input signal, that it creates an output signal that potentially kills somebody or does something very adverse that we don't want. And it's also very inefficient. So we are always more efficient, we are always faster if you write a linear code, because that's basically the mathematical optimal solution, or can be the mathematical optimal solution to come from an output to an input. So there's no right and wrong in this. And what we've seen is that exactly that is what happens with ChatGPT, with a neural network that is optimized for the task of creating texts. And what we've of course also seen, and this is important now for today, is that neural network is not neural network. So it again is a super cool tool, but as you have seen yesterday, there is a lot of other intelligence that goes into this neural network to make it think or to make it behave like a text generator. For example, the tokenization, for example, the embedding space, for example, the attention mechanism, for example, the temperature which we discussed, or the top P. So there's a lot more that's going to it, not only the neural network, which is of course the key part to this, which makes this behave in the way we want. But now we go into another kind of AI that is also powered by neural networks, of course, which is image generation. And here the architecture, of course, is fundamentally different. Basically try to get from an input, which could be, for example, noise, so thermodynamic noise, Brownian noise, to an image by reducing the noise or in some way. So there's a lot of thinking again, a lot of ingenious thinking again for a completely different kind of problem. And still, since neural networks are so versatile, basically just saying, you computer, come up with a solution for this problem yourself by doing things you do best, which are calculations, trying to solve for images. Why are image generators very cool? Because you can do so many things with them. You can create drawings. You can create drawn books. If you go to Amazon, apparently there are a lot of AI-generated children's books where a GPT created the text and a image generator created the drawings. I heard that when you go to Facebook these days, then you only see AI-generated images and nothing else anymore. I haven't been on this platform for so many years, I don't know. And I don't really want to go to this platform anymore. You can also create photorealistic renders. This is, of course, something that a lot of you want, particularly when you're thinking about startup, how can we get some first assets that we can put in a pitch deck, that we can put on the website, that looks somewhat good. For me personally, I have the feeling that they all have a kind of similar vibe to it. So you tend to see what was AI generated because they are always a little bit too flashy, a little bit too clean, and a little bit too over the top. And then, of course, there are always some problems that could not work in the real world if you just look close enough. And you can also get the artistic styles that you want to. Again, this is then by training. So these kind of models are, of course, trained on all the image information with image classification. So they are trained on watercolors. They are trained on painting in the style of Dali, in the style of every artist that you might think of. And thus you can basically create every single style that you ever want. And of course, photographs. I know of one location here in Munich that for its Volt menu, so for its takeout menu, they created all the images with Midjourney, so all AI generated. And they look great, but as you can imagine, the feedback on the takeout side is that the food that arrives looks nothing like the pictures. Which I guess makes sense. If you put AI-generated pictures like this, you get a hot dog, and this is the AI-generated picture that you put on the website, and then you get a real hot dog, which of course cannot look like this because this is AI-generated. So this also goes a little bit into the ethicality of using AI. I think this afternoon we will also think about or talk about the legal concerns which go in the same direction. So I heard, but Richard will tell us that you need to attribute AI-generated images, and I think that's only fair for the user to say, okay, this actually is AI-generated. This is not a representation of what you will actually get. That's true. So the what you're saying is that the faking basically is a artistic art style that has been around for every kind of food. That for example the steaming buns were not steamed from the buns, but just a heated cup of water in the background. Yes, that's totally true. And I think that makes for a super interesting ethical argument. So where do I draw the line? Just because I'm not being in a photo studio anymore, but using an AI, is this now more unethical than when I use plastics to photograph what I'm actually seeing? And the same for when you, for example, go to McDonald's, what you have on the menu and what you get on the hand has also no resemblance, right? So I don't know, but it's a very good point. There's another question. The question is, do we have technical solutions to basically see if assets were generated by AI? By text, it's super hard because text can be so average and so normal. Just if you have a very standard tweet, for example, this can be so easy and so standard that it's super hard to find out if this is AI generated. OpenAI has come up with a tool that tries to give a probability how likely it is that you generated an essay, for example, what high school students like doing by AI, or if you've written it ourselves. It's not very accurate, and I think as long as you get the key things down, so what ChatGPT always does in the end, it says in summary, and then one paragraph. And if you leave in this in summary paragraph, I think you as a human can say, okay, this is definitely ChatGPT. For images, it's even harder. For images, it's hard for technical attribution. Sorry, it's not even harder, it's simpler. There's no technical attribution, so there's no watermarking system. There's no, yeah, you can put metadata as you want. However, the way it's generated, we will see, is basically from noise and try to denoise it. And the remaining noise in the image can be a good sign that it might be generated by AI. What you can also see as a human, it's actually quite easy to see. Unfortunately, you don't see it here, but on my screen, which of course is better, you see that below the sausage, the hot dog bun does things that are just not possible for a normal hot dog bun. So it basically slices up like this, like it was baked that way. So this is not possible. And I think in almost every AI-generated image, you will find these kinds of artifacts that are just not working. We will today have tons of images where you can probably see in every image at least one problem where you say, okay, this definitely is AI-generated.
I was
Yes.
walking in the offering yesterday. The Canva, which is I guess they mostly use ChatGPT, the API.
Yeah.
Canva actually provide the watermarks. So the images that are created by Canva,
Uh-huh.
it says actually Canva is a watermark. Very similar to
Mm-hmm.
Getty's images. If you're actually trying to
Yeah.
pull images, Getty has the most images database, and
Uh-huh.
if you try to copy or then always Gary's watermark is
Nice.
shown
Yeah.
on the images. Very similarly, I noticed that Canva, but the ChatGPT doesn't have that.
Yes, exactly, exactly. And I'm also not sure where it does it in the process. I would imagine that it first generates the image and then puts a static watermark on top. So the removal of the watermark was probably also a little bit easier. But there's definitely, so I'm thinking that there might be ways to put it in the generated artifacts that you have some kind of watermark, like the HP printers do have, that they basically print a kind of secret code that when you're printing some kind of legal document, that you can know what printer it was printed from. Okay, the usages for this, of course, are endless. You can put it in film and entertainment, marketing, advertisement, corporate design, social media. There's just so many things you can do. Of course, very much dependent on what stage you are. So I think still that we are in a stage where it's mostly working with MVPs and the early stages of your startup journey. Also, when we're talking about product design, it can give you a kind of design language, but when you look at this picture, not a single product here does make sense. But in the general look of it, it has a nice aesthetic. For example, this watch cannot be worn, this watch can neither be worn. I have no idea what this or this is. So that does not matter too much, but it gives you you can shortcut the way of mood boarding stuff, of saying, is this the general aesthetic that you would like to go with the kind of brand that you have? Again, we discussed that yesterday. AI does not have concepts of how are things meant to be, so it doesn't have concept of a watch. The same you will have for architecture. This might look like a nice house, but this is nothing you could really live in, or maybe not even build, because it has no concept of statistics, of statics, of how humans, of the human autonomy that need to get into this house and out of this house. But you can use it for a lot of things. And as I said, there are other tools which is actually quite funny. Just jump to this very quickly. Tools like Udio, for example, where you can let AI generate your coming up. Yeah, generate your entire songs and listen to AI-generated songs that are surprisingly nice for the first 2 minutes and surprisingly dull for the rest of the time that you listen to it. But it's cool where we actually already go with that. Okay, a little bit more of the technicalities, because this is basically giving us the understanding where we're going now. the key thing that or what a lot of people have agreed on, what we should look for is start with noise and try to denoise or renoise things. So a first very simple way of doing this is with variation autodecoders, which basically means we start with an image, try to compress that and lose ever some more data until we are at a point where we are in a latent space where you basically see nothing at this picture anymore. But you start with some picture, let's say of an iPhone. This iPhone gets now so compressed that you cannot see anything more, but somewhere in this noise there is the information that there was a smartphone held in a hand. And now we try to do the opposite process. So we try to step by step take away of the noise until we have until we have a sharp image again. How does this work? How can we imagine that? Basically, you have some noise, so it's very unsharp and you don't know. So it's basically the same thing that you do when, not basically the same thing, but it's similar to when you take a photo and then you try to increase the contrast, you try to increase the sharpness. So that is what you do on a very unsharp, very noisy picture. Every step you try to increase a little bit on the sharpness and try to make the distinctive parts a little bit more distinct. So until the end you have a sharp image again, and hopefully this comes out with what you want. This, of course, being a rather primitive technique. It can work on pictures that should resemble some pictures that you already have, in particular in the layout, but it's probably not the one serve all solution for what you want. Let me jump over the other two, because what I want to focus a little bit is the state of the art, which is stable diffusion. And in stable diffusion, basically the name gives it away. You start with Brownian noise. So the first picture is just randomly generated noise. So there's no information whatsoever in this picture. And then it predicts or tries to predict, for example, show me a picture of an apple, and then it tries to predict the next stage. Okay, how should the noise look like in the next iteration? So it tries to detract the noise that it predicts from this perfect noise, and does that iteratively through every stage. So it goes through this 100 times, 1,000 times, always putting out a little bit of the noise, saying, I want a picture of an apple. Okay, if I want a picture of an apple, then this kind of noise should now be distracted from the noise that I originally have, and goes until the point until it has a picture of an apple. Am I losing you, or does it make sense? So, for example, what you will see when you look at this process is that in the first kind of iterations, it will not create a picture of one apple, but since in the training data it has pictures of apples here, 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 then it proved baskets with 100 apples, the first kind of denoised pictures will look like it goes in a direction where it's a picture of 1,000 apples, like a wallpaper full of apples. Looks all very crappy until at one point one of these apples, probably, or a totally new apple, becomes the predicted next step, and then only it basically generates a one apple out of the clutter of a lot of apples. Maybe we can actually see this on the stable diffusion side. I think this is where I have it from. This is what I'm trying to describe. No, it doesn't tell me. Oh, that's so sad. Yes?
What I understand here is that we are now looking at from picture to picture, right? Or is it?
It's one pipeline.
Sorry?
This is one pipeline of a picture. So we're not taking noise and then looking through a library and trying to basically make the difference between the noise and the library picture and move that and go through the entire library. But we already have a pre-denoise. So when I say I want an apple, then it calculates the noise that it expects from a picture of an apple based on this attributed library of pictures of apples in the database. And it goes through that and does it again. And then it goes again through the denoising. So the next step that it has, which is still very noisy, but a little bit less noise. So maybe the picture of the dog is a better example because it's on here. So we have a noise, there's definitely not a dog in there. Then it goes through the denoising, so looking at picture of dogs. What should the denoised picture, a little bit less noise, how should a little bit less noise look like? And detracts it from the noise that we have. And then we have something like this. And here we can also already see, there's probably something that should look like a dog. And it goes again and say, okay, if we have this picture, now let me predict a picture of a dog. What kind of noise should I retract? A little bit of noise that I should take away. And I do this hundreds of times until I'm at a point where I say, okay, this actually looks like a picture of a dog now. It's a very complicated and very ingenious method. I agree. It's a little bit complicated, and I also don't, of course, know the ins and out of the denoising process of the denoising model. So this would be again the denoising model, the machine learning part that we actually have. This is then just linear algebra. Sorry, there's another question. The first picture is really just random noise. So noise, of course, you know noise in the terms of sound. It's basically in the terms of sound, it's all frequencies being randomly distributed. So 540 hertz is a little bit loud like this, then 531 is a little bit less, and this basically propagated over time. So you have a random distribution over that. In the terms of pictures, that can be exactly the same thing. So every pixel has a color, a hue, and that's it. Sorry. And this gets randomly calculated for every single pixel. So you start with really no information whatsoever. It's just a completely random noise. There's probably a method to the noise, and that's probably also one of the secret sources that people try out. So there are different noises, Brownian noises. You can have different colors of noises. So you can choose that you don't have a completely randomized picture. For example, Brownian noise would say, okay, then when you have a perfect white pixel there, you cannot have a perfectly black pixel next to it, but it needs to follow in some gradients that you can have there. But in general, the first picture does not come from any knowledge on from any kind of training data.
Now I get it. We have like this random picture, and then we put it through the already trained neural network.
Exactly. So it basically tries to pull a Michelangelo on this, and it says to create a David, you just take off the stone everything that's not the David. And this is what we have. We have the couple of stone, and it tries to put everything away from the couple of stone that's not a corgi. There was a question?
So it's just distracting, it's never adding, right?
Yes.
That would assume that you have pixels like from the three colors, whatever, red, blue, and the other ones. You would just, like how intense they are shining, you would distract until they get the color they are supposed to be?
It detracts noise, so it can add new colors. So it's not the case that if we start with a grayish, noisy picture, then the outcome is also grayish, noisy or grayish. You're just detracting the noise. Meaning, think of that you take a vibrant photo of people in the English garden, and then you just put a very noisy, cloudy filter on that. Then you're still detracting or try to detract this cloudy filter and still come up with a vibrant scene. Although if you were just to detract the remaining colors in that, of course, you would come up with something very dull. So it's still just detracting, but that doesn't mean that the amount of color and the amount of hue and the other amounts of information must be reduced in the final picture. There was another picture, question?
Questions. The first one regarding like where the prompt is taken into account by the model, because I now think about Midjourney or DALL-E or whatever.
Yeah.
You generate images from a prompt, right? Is it like the denoising model that takes it into account instead of outputting text, it outputs pixels or like multiple pixels?
Yeah, no. Super good question. That's not even in the picture. So what it basically does is that of course we have our library and of images. So let this be an image. And these run through a classifier. So this is a completely separate set of machine learning tech, which, as we talked yesterday, is also nothing completely new. So this classifier basically just attributes and say, okay, this is a person of a human. We see the head. It's kind of half cut. It's central. It's a white male or whoever, and puts this attribution basically on there. There are also libraries, a lot of big libraries and also open source libraries that have pre-attributed pictures already. And now I can have a kind of space where I say, okay, for example, here a picture of white men, then here are pictures of food. Here are cat pictures or something like that. It's probably the biggest space in this picture space. But when we then try to go to and say, okay, please now create me, so now I go and make a prompt here and go through the image generation process and say, please, from this noise, create me a portrait picture of a white male. For example, of course, can be everything else. Then it looks at the information that it has from the classifier and say, okay, wait, I have 1,000 pictures of white males. Of course, it has a way smarter way. They are not stored as pictures there. I actually don't know how they are stored there. And then it tries to look at features that they all have in common. And according to this, what they have in common, they try to create the denoise model and add it or distract it from the noise that we have. And there's, yeah, it becomes even weirder because when we say, okay, I want to have a picture where on the left-hand side, I want to have a cat. In the middle, on the right-hand side, I want to have a child. In the background, I want to have mountains. Then it does not only, it of course does not look for pictures who have exactly this quality, but it tries to split up the picture. It tries to think of itself, okay, what kind of pictures do I need to look for? So here I need to create a cat. Here I need to create a child. Here I need to create a mountain and stuff like this. And it tries to add all of this together. And this is super complicated. And as we will see from the different output, they are vastly different between, for example, DALL-E and Leonardo or Midjourney, that every technology makes it very, very different, or every supplier does it very differently.
Does it mean that in your example that you asked to generate different elements in the picture, that they're also different, like that the program or the AI generates different like vector representations for different kind of parts of the image, like what you
Potentially. That's something that can happen. There are also tools where you can make local prompting. So you have a final picture that is very complicated with thousands of people and stuff. Where I can say, okay, now only in this space, add a bow tie. I actually in the bonus in this online. I wouldn't call it lecture, but in the slides I only put online, there is an example of how you can do local prompting as well. I can quickly show you that if you stay with me. I see you. this does not really have something to do with how the images are generated. This is more a prompting technique, but let me very quickly jump to, if you see a frog, then tell me this is not a frog. This is an yes, there it is. Here you can see it. So this would be regional prompting that in a way, so this is for prompting where you just tell the model, okay, I want to change the frog, I want to change the suit, I want to change the bow tie. But I would assume that the more advanced models are capable of doing something like this also in the generation process, where they say, okay, I have a frog in the background and I want to have another backdrop. Of course, they don't have concepts of what is a background, what is a foreground, but they know that this is a region where there should be a frog. Your question?
Yes, I have a question regarding the original inputs. So what I hear is when we are talking about generate me a image of a dog or so, we have a huge training data of dogs available, and there the denoising is pretty easy. How does it work when you do not have such a big database? For example, if I say, draw me a picture of a jellyfish or so, and there are only a few dozen jellyfish pictures or so, how does the process then work?
The same way, it just will look more similar, more equally. So if you find a prompt where in the space, in their embeddings or in their classification, you only have one single source, then it will look exactly like this one source. Yeah, this might be a cool challenge, but I can't think of one way. In all the online pictures, you only have one source. But yeah, definitely true. The more you have, this is also the cat. There's actually a cat photo problem that photos of cats you can generate basically endless amounts, but every frog will look a little bit like this frog because there are so limited number of frog pictures out there.
Maybe it goes further in the topic of when companies are using AI and want to train them on their own data. Typically, it's a smaller sample size than when you look at the picture of dogs and cats.
And this is what's happened. This is what happens in image classification for ages. For example, Apple used to have the problem that Face ID worked better with white people than with people of color because there were just more trained pictures of white people than people of color. And they of course fixed this problem. They at first were not even aware of it. But there's of course, you again, like yesterday, garbage in, garbage out, you need to fix this part and make sure that you have a fair representation of what you want to, in the end, also get out. If you don't have the fair representation, or if you just train it on middle-aged male, then of course you will have a hard time finding in the end a good classification for younger women. Which again, of course, is not because people are evil here, it's just a technical limitation. Okay, let's maybe jump into diffusion models a little bit deeper. It's generated in 2015, so again 2017, attention came up. Attention was helping us with the language generation. We do not need attention for what we're doing with images, and image recognition also is a solved problem. So we could, on the classification part, so this right-hand part was already solved when we came up with a generation, which of course was fantastic. And since 2020, we have a huge uptake in stable diffusion. Stable diffusion, of course, was just built next door by Björn Ommer at the LMU, which is fantastic. And diffusion models, in a way, either open or closed source, are the foundation models or the foundational models under Midjourney, DALL-E, Stable Diffusion, and so many more. And there are two things you might know. There's first unconditioned generation and then conditioned generation, which goes a lot in the question, where does my prompt come in? The first kind of solutions were unconditioned, where it just says, create out of noise, create a person in some way, and was just taking a huge library of headshots, and from this headshot it would create new images. Whereas the condition generation now is a way harder problem, where we want to say exactly what we want, so being super versatile on what we want, and create basically everything. Do you know this person does not exist? This has been a by now very old website, and all it does, every time you reload it, it shows you a person that is instantly generated by AI. So none of these person existed, or still does not exist. It's a rather old image generation tool. I think they all look fantastic. For that, they are all being AI generated. Probably for most of the people, you couldn't tell if they are AI generated. Maybe if you look long enough, you see things that don't really match up so well. But this is an unprompted thing. They are just taking a lot of headshots and basically getting a new average headshot for another person. Of course, it has to make some decisions, what kind of sex it wants to show, what kind of features maybe it wants to highlight and stuff like this. But as you can see, very old tool, which you can get basically unlimited number. Here, for example, here you can see that it's definitely generated by AI, because I have no idea what it tried to get here. But this is one thing, unconditioned generation, already being out for quite a while, and I think already being quite good at it. And the conditioned now is the other part that we try to get now. We want to create not only random images of random people that don't exist, but we want to be able to give it some text, and for it to give us some results back. So, and this is exactly, again, the process. Maybe this is a little bit helpful. So, up top, we go in the direction of noising. So we are sampling the data, we have our dog, and add a little bit of noise every single time. So a little bit of noise. Here you can also see, of course, the noise. Yes, I detract the noise of it, but this doesn't mean that the dog will have colors that are already in the noise. The noise is just another level that I add. And when I do this often enough, I can predict, of course, by the denoising, that I say, okay, the difference between xt and xt minus 1 must be the noise I added. Makes sense, right? So when I reverse that process just often enough, of course, on this perfect picture, and I know exactly the noise I added, then I can reverse this process, because at every time I know the picture exactly and can get back to x0. When I, of course, do that for a huge number of images, then I still can now create an average and say, okay, I'm at xt, I'm at perfect noise on xt. And I know from all the pictures of dogs what xt minus 1 should look like. So I do that and then can generate, if I do that just often enough and receive x0 at some point, I can get to a picture that is a dog, which is not a dog that exists. Was that? I think this is a little bit more visual, and it's, of course, this is just the picture of the dog, and this is again the hard thing what we're trying to figure out. Of course, if we just want to dogs in this pose, and we just train it on the dogs, it's a rather linear and rather straightforward process. Actually, it would be quite cool to build such a tool ourselves. But now if you want to say, okay, I want to have a prompt, then this function that I have, this P0 function, of course becomes insanely complicated. And there's again where we probably are not good with linear programming, and probably need some kind of neural networks. I love mathematics, yes?
Is there some kind of general perfect
I don't think so. I think everybody comes up with their own noise picture. You can even let noise be created for yourself. So basically, it's a random process. Do it yourself. But I'm very, oops, that was wrong. I'm very sure that you can add online noise. Yeah, fantastic. You can probably find a lot of. Oh wow. Yeah. So this is really something that is already solved, and then you get some random noise, which is also a very straightforward mathematical function. And I think everybody, or at least the companies who try to make money out of this, let's also close that. That's freaking me out a little bit. The companies that make money will have had some research. What is the best noise to start with? Of course, the hard thing is that once you have decided on the noise, you should not change the noise, because then if you restrict from a different noise picture, the noise, then you of course come up with nonsense. Because you end up with a perfect noise and then have the noise differences that you have. Now, change the perfect noise picture to another function of noise. So for example, your noise is now perfectly white pixel or perfectly black pixel. Probably a very stupid kind of generating noise. But let's say this is the way you start without. And then you change it to this kind of noise, or Brownian noise, or some other kind of noise. Then you're distracting information from a original set of information that does not make sense. Hence, you never come to a convergent space that the noise distraction comes to something that can resemble what you started with. So you would have to redo the training.
So I always, when I train my network to detect dogs, I always try to get from the dog picture to the same noise.
Yes, kind of. Yeah. Exactly.
That is also deterministic.
That was
Deterministic.
this. Yes. If you now make it for perfect. So I imagine that this person does not exist, just starts with randomly generated noises, and then there's a deterministic point to that. This is deterministic but chaotic. So if the noise is a little bit different, the end result will look completely different. And this is the beauty of that. And I would say that this is still deterministic, but when you of course prompt it, it is super chaotic. So you start with a chaotic noise already at the beginning, and then you have prompts that then also are chaotic. So every step in between is chaotic. So yes, if you run it a second time with the exact same parameters, you will come with the same deterministic result. But as soon as you change one of the parameters, you will get something completely different. What we will also see in a minute with the deterministic, for example, if you call Delhi and say, Delhi, I want a red sports car, and I want a red sports car in that direction or the other direction, those red sports cars always resemble Ferraris. They always look like Ferraris because apparently in their training set, red sports car was always just Ferraris. Which can become so repetitive and so boring at some time. But yeah, that's what I mean. Was there another question, or was it so? Yeah.
I don't know whether I fully understand this diffusion model, but there's an artist, Salvatore Dali, in 1977. He created this lithograph art called Lincoln in Dali Visions.
Mm-hmm.
So if you look at the images close by,
Yeah.
there's a naked the ladies. But if you go far beyond, far distance, then you'll be able to see the Lincoln's portrait, if you will.
Ah.
So noise in that art, noise itself is intended. So I actually using ChatGPT, but even though that's not a diffusion model, see whether he can create the Lincoln in Dali vision type.
Yeah.
It's completely realistic. It's not really being able to create the
Exactly, exactly. Exactly. It's a very good point. I also have the feeling like it's very good in creating the macro level. But if you say I want some intricate details in that, that's mostly considered noise or something noise-like, noisy, that and tries to get rid of that. Which is also there's also a sweet spot. So if you say create a very simple brand image for me, then it's oftentimes too easy and it cannot come up with that because it just adds so many details. And if you, on the other hand, want something super complex like a football stadium full of fans, it's usually also hard with that because the end still has so much noise and super uncanny valley results that it's also very hard to work with. So I think there's a sweet spot of tools of level of detail that you can work with.
Why is the AI so bad in generating text in the images?
Because it does not have a concept of text. So what there are different approaches to different things. The first thing is that at some or one of the best things is that at some of the stages, like a Microsoft Word art, you just write the text out and then you say, okay, this is now part of your picture and try to denoise it as follows. This is also part of the slides that I have put online as the bonus stuff, how to work with text and images. And one of the easiest ways to have good results is to keep the text as simple as possible. So just make it 3 words, 3 short words. This is something it can still work. If it's too much, then of course the diffusion model has to find a way of how should they be rated. Is this, so for example, you have an entire page of a book, and of course this looks very much like noise. Or we know that it's letters, but for the AI it just looks like noise. And why does it put this somewhere in here? Because it must be early enough that you can affect for lighting, for stylistic changes, and for all the stuff that make it part of the thing. If you just put it on at the very end, you could just do it yourself in PowerPoint, in After Effects, or in anything. And if you put it too early, of course, it just will be noise or it will dominate the picture. So this is a hard thing for the AI to get right. Yeah.
Why can they not just put another layer on top that after the image is generated finds the perfect place and format where to put the text?
I would love to have that. Maybe this is an open innovation. Actually, the approach sounds really clever. So you basically try to generate 2 pictures from the same noise, one just the text and the other one in transformation method. Go for it. That sounds like a $1 billion idea, actually. Okay, we have gone through this very, very long time. So exactly the training and inference is exactly what we were discussing. So the training basically takes the perfect picture and then noises it up step by step, and we learn the noisy steps in between. So we try to predict we have the predicted noise as an output which we can work with. With that we can update the parameters, and then in the inference we basically try to use the predicted noise to regenerate the image, and not necessarily only the perfect image that we have, but something that is a little bit different. Very smart way actually to do that. And of course, in the training, just for the shows, you know the problem that it's sometimes hard to distinguish different things. On the top left, we have, is it a dog or a donut? In the middle, of course, you probably know that. Is it a dog or a blueberry muffin? Which is sometimes hard for the AI to figure out. Or on the left side, is it a dog or a mop? And this is probably something that is also fun to produce. Create me a what's the name of the dog? Is it write me a chihuahua next to a blueberry muffin or something like that, and see out if something useful comes out, or if it just messes up because they just look so different, so similar. So yeah, a lot of problems had to be solved on that. Also, the reason why we solve so many of the problems also in image generation, of course being a very old topic in machine learning and AI, and text, is because everybody's researching on that. Everybody wants to do that. There are huge progresses right now. We can assume that in the future the progress will get a little bit slower, but I think it's super cool to see what we can do. 2015, it all started with StackGun, is the AI used for the random face generation. Stable Diffusion in 2021 is basically everything other thing is based on that now. Then we have DALL-E 2, we have DALL-E 3, Midjourney is on version 6 and stuff like this. So it's really a lot is happening at the moment. That's what Jan Bastian added. If you want to learn more about the technical ins and outs of that, there's Deep Learning AI. I think this is the course by Andrew Ng. He's a fantastic teacher in the field of AI. I think he has an open course, How Diffusion Models Work, if you want to learn more about this. The strengths and limitations of the diffusion models. Of course, those models can speed up your work process by quite a bit, in particular if you need some starting points, some random visuals for what you do. It's always a fantastic starting point to just drop some images and say, okay, let's try to work with them. If you're a visual designer and say, I want some starting images and put them into Photoshop or do something else with them, I just need to have some patterns. Yeah, sure, use them. It's fantastic. It speeds up so much, and it takes up so much of the vanilla work. Same for programming, what we talked yesterday about. It will not write the perfect programs for you, but it will take so much of the vanilla coding for you. And same is true, of course, for image generation. You can also combine new ideas to just try it on if things work visually as well as you think they might work in your head. So visualize new idea, conceptualize new idea. That's really a perfect thing that they can do, but don't expect them to solve your problems. For example, if you're thinking furniture, AI-generated furniture, they don't know the human geometry, what is nice to sit on. They always have some problems. They don't know how production works. So if any of these is producible, that's nothing they know. They don't know crafting. They don't know handymanship. So it's nice to create some visuals, but in the end, you still have to do the designer job to make this something that is affordable, producible at a price point, and crafted from sustainable resources, and of course also be nice to sit on for some people. So it's really just the early stages that it solves. So also it's again garbage in, garbage out. So it depends very much on the image you give it, on the prompt that you use. For example, those are the same model with two different prompts. So of course that makes a huge difference. Also, I think on both pictures we see that they are AI generated. Left, of course, is AI generated. The guy on the right hand side also has a lot of details that show that it probably is not working in the real world. Like his zipper is totally messed up and stuff. Then what model is being used? On the left-hand side, we're using DALL-E 3. On the right-hand side, we're using Midjourney. Here you can already see that Midjourney is a way better model than DALL-E for creating something that is a little bit more realistic. On the left-hand side, again, we see immediately it's AI generated. The right-hand side as well, in particular, the guy here in the back seems a little bit unhealthy. But I think if we just put it on a website and say let's call it a day. So maybe if I want to create, because of course I don't have time to also make pictures while I hold the lecture. So maybe I just photograph the empty lecture room and let AI fill it with 300 students. Then I would probably use Midjourney for that. And then also the kind of data it's trained on. Here we have two times basically the same prompt. Of course, here we just adjusted the prompt and say one, we want a photorealistic model, and one, we have a cartoon. But of course, this now looks at the trained cartoon data, and this looks at data of realistic cars. Hence, it has to make the decision at one point, am I going for the right art style, am I going for the left art style? Yes?
Short question. Is it possible with Midjourney to include things on top of an existing picture you upload? Because I tried
We will
to-
go to that.
Okay.
I think we can skip a little bit over that. The key point is, but I think I've made this clear, it's not solving your problems, but it's giving you input for the work you are doing. So if you want to generate a single image, then of course you need to put that in your website, on wherever you want. And also when you're serious on creating assets for your website or your product page, then please use something like Midjourney, because in particular if you send it to investors, they are so sick of seeing daily images in pitch decks because they all look the same. It's so boring to look at. So at least take the time and spend the €8 or $8, whatever they are, on Midjourney to create nice visuals. Because so am I, by the way. So I of course read a lot of pitch decks as well, and if I see the daily created images, they just look so uncanny, daily. It's really dull. The other thing is that's why we do it today and not yesterday. Actually, the limited control over the process of image generation. It's way less straightforward than creating an output for text, because we know that describing an image is way harder than describing what should you do as a text. So it's way more. We need to way more operate and way more think about how should we look like, how should we think about the models, what do you want to give me. So the first thing that you get from a prompt is usually just a suggestion. You need to take it as a suggestion and say, okay, when I put in this, then I get this outcome. Actually, I want something completely different. So never expect, in particular for the free models, to get with the first shot of prompting something that resembles what you want to have. But it is an iterative process. It is also some kind of work. But if you don't have the time to do the shootings yourself, or the budget, or anything, then it's still a very, very good point to do. And again, in your workflow, it is super helpful if you do have some Affinity Designer, Affinity Photo, Photoshop, whatever your tool of choice is, skills to continue working with those, or even Canva, because at the end the fine adjustments is something that you probably want to do by hand. Okay, and of course the limitations are with it still does not have any concepts, and this is what we see with hands, for example. I know it's hard to draw hands. I still can't do that. I couldn't do that in kindergarten. I can do it now, and AI still cannot do that because, of course, it tries to. I think we can understand this now. How it generates the images. So it tries to take away noise, and what it sees are sometimes fingers that are like this before another hand. So it tries to do that, and it does a good job, but it does not a good job of counting the appropriate amount of fingers, the appropriate amount of hands, the appropriate amount of arms. It does not go back to the image and check, does it actually make sense in a way, but it just tries to take away the noise until it comes up with something that somewhat is similar to what it was trained on. And everybody is shaking hands. It's all shaking hands. You cannot tell the computer that it did not do its job. You just wanted to have realistic shaking hands, and you did not really specify for that, did you? And this is the general thing that you have a lot of with a lot of human features, in particular if you want more than one human, that you have so many uncanny valley features that just do not look good. So you need to be very outspoken, very explicit on what you have, and then rather work with Photoshop and fix those problems with yourself. It also does not know numbers. For example, how many teeth does a human have? No idea. If you have people in the library who are missing some teeth, some front teeth, then you come up with a very uneven number of teeth at some point. So this can be a little bit hard. And then, of course, pictures tend to be very over the top and very stereotypical. So if you're asking for a sports car, you get usually a hypercar. If you're asking for food, you get the very stereotypical things that you have. For example, the most German meal, and then you of course get sausages, you get beer. I think this should be beer, although it looks like booze. I have no idea what this should be. I think it should be egg. And the same, of course, is true in the US. You get burgers, which looks super disgusting if you ask me. You get a lot of French fries and other stuff which I can't make out. And if you take Canada, for me it looks a little bit oriental, but then you have two Canadian flags here. So it's just super stereotypical and not really necessarily helpful to what you want to have. So be a little bit more specific on what you have and don't go too much overboard, over the top. Legal, I put this here as well, but we have time later to go through it on detail. So the easiest things to say is that although it is created by an AI, you're not necessarily allowed to use it. So you're not necessarily the owner of the picture, and in particular, you might even not have rights on the picture. For example, if you create what I did for this example with the video game, I asked DALL-E to create a 16-bit Super Nintendo-like jump and run character. It gave me a perfect Super Mario. Of course, I can't use that. That's property of Nintendo. So you can. It has safeguards. So if I say make me Super Mario, it will refuse to take this. So again, this also has a data pipeline, and it's also checking for the input. And if the input says create me David Hasselhoff drinking a beer, then it will say I'm not creating a David Hasselhoff. But on the other hand, if you find a character David Hasselhoff played or something else that give me a Hasselhoff-like character or something like that, it will create something, or it might create something that looks very much like David Hasselhoff that's holding your product in his hand. Of course, David Hasselhoff has the rights to this, so you cannot use that. Despite it's not being a photograph of David Hasselhoff, and it might have some features that don't look like David Hasselhoff. Those are the two things that we should think about on the very high level. In detail, Richard will tell us this afternoon. Okay, now let's take a look at the most relevant technologies and techniques. We can choose from a huge plethora of tools if our company allows us. One thing that is very easy to access is DALL-E 3 from OpenAI. It's either accessible through ChatGPT. There's also a tryout site somewhere on openai.com, at least there was, or via Bing at bing.com/create. We can also access this model completely for free on Bing. It looks like this, and you have 15 tokens per day to just create an image that you can use. Or I should charge my laptop that we can just use. In my opinion, still best tool is Midjourney. Why? Because it just creates the best images, and the images it creates are also adaptable, and you can do a lot of other things. Similar to Midjourney, but a little bit with problems that all of the pictures look very similar, is something like Leonardo.ai. It's not on the website. You can use that also for free. It has so many tools as well, which is kind of cool to try out. I liked it in the beginning, but then again I found that all looked a little bit similar, so I stepped away from it. Another thing that you can use, in particular if you're an Adobe customer, is Firefly. Google DeepMind has something like Imagen, which I'm not 100% sure if it's implemented in Gemini. And then, of course, we have Stable Diffusion by Stability AI. It's an open source thing, so that is something you should always be able to use. And a lot of companies are also making their own image generation AIs based on Stable Diffusion. So I know Munich-based of one company that has built their own generative AI tools based on the open source opportunities that you have here. Delhi is quite nice because it's so easy to use. It's very beginner friendly. You can just interact with it like you would with ChatGPT. It's also quite cheap. With Google, you can with Microsoft you can use it for free. With ChatGPT Plus, it's in your ChatGPT Plus subscription. The cons, it's not super great. So the pictures all look a little bit of the same style. You have very little control of what you want to create. You have just the ability to work directly with text, and it has a lot of guardrails, so it's very limited. I tried once to create a very, very usual prompt. I think it was a person standing at a fairground or something like that, and it didn't allow that because apparently it was violating some guardrails it had in place. So it's a little bit restricted if you want to do something. In this case, it was a person in a disco dancing, and it thought it was too sexual. The quote. I don't know what it wanted to create for me, but I really just wanted a person in a disco in the style of ABBA dancing. But this might be a little bit frustrating if you need a very specific thing. And prompts are limited to 400 characters. Should not be really a problem if you stay with short prompts. Then you have Midjourney, the great thing that it's for €8. If you use it properly, then it should be quite nice. It is through the AI of Discord, so you need to learn Discord then, which might be a problem. And it's really fantastic. It really creates high quality output. Has a high accuracy, and you can adjust the pictures very easily. You can also have parameters, which we will look at in a second. The cons, of course, is you have Discord as an UI, which has some pros and some cons. If you know Discord, then I actually find Discord a rather cool tool, but it's not really meant for image generation. And the results that you publish are completely public. Let's quickly show you the both. So if we have DALL-E in ChatGPT, then it of course looks like this. You create a new chat, you open your DALL-E, start the chat, and the only thing you can interact with is you interacted like you would do an open text. On the other hand, I already have opened Midjourney here, the Midjourney bot, and had a class of students going nuts about the amazing high-tech content the professor teaches them. Let's see what we get when we put the same in DALL-E. Let's look quickly at what we get here. I think those pictures are actually quite okay-ish. All of them have very huge problems. All of them look a little bit unrealistic. I also did not specify what thing I like. I think the one on the top, on the bottom left is the one that I would be using if I had to use something, because it's something that maybe I put in my LinkedIn post tomorrow, how it was today. So this is what it does. As you can see, of course, you have to move through it through Discord. For that, you have to learn a little Discord. And here, of course, you have those typical DALL-E pictures. I hope you start seeing what I mean. They all look a little bit the same, and they all look a little bit boring. And those lifeless faces will haunt you in the night. It's really a little bit scary. But yeah, you don't have too much control. For example, the next quote that or the next prompt I make would now it would take in the context window, because still I'm interacting with an LLM. It would take everything we talked about in the context window of generating the prompt. So this is not direct the prompt, but ChatGPT creates the prompt for me based on what I want, and of course it does that based on everything we talked about. Whereas here in Midjourney, I have perfect control of the prompt because I'm writing the prompt myself. There's a question?
Something I just noticed, I don't know if that's like by accident, but I think with ChatGPT you just put a bigger hint, right? Like Dolly, like
Yeah.
because there it was like a very diverse group, like lots of females and males. And
Yes.
here in Midjourney, I noticed like it's only males, like especially in the center of the picture, like the Mac era, Zoe, there's not a woman, but it really catches my eye.
That is a fantastic comment. So the Midjourney pictures look less diverse than the DALL-E pictures. This is because of the data pipeline. I wrote the direct prompt. The direct prompt was students in a high-tech environment. And so the training data will definitely have, I cannot guarantee it, but I'm rather sure that it will have predominantly male students in the picture. So it takes directly what I asked it to. So it is my job now as the image generator to say, well, this is not very diverse. So I'm also agreeing this person could be a woman that is blurred in the background. But do I want to have this, or do I need to think about more diversity in here? Is this okay for me? Is this not okay for me? Whereas, since I'm interacting with a large language model here in the first place, ChatGPT itself adapts the prompt and says, okay, I actually think you want to have that. And when I tell it, please create a classroom full of white men, then it might actually not do that, because it tries to go for diversity. But yes, it's true. Of course, it's to think, what am I going for? Even if this was photorealistic, probably nobody would believe me that we would have such a diverse group in a Munich classroom. Whereas this, yeah, Technical University of Munich sounds about right, that they are only male. It's
But does it understand, like, does it differentiate between male and female? It doesn't understand whether it creates pictures of male or...
exactly. It does not understand that. However, if I wrote them, let's take the exact same and say just diverse, then it would probably look for a little bit more diverse. Diverse pictures in the background, and probably, oh, sorry, I'm an idiot. Of course, I need to. I think I cannot do this like this. I need to make a new, because the prompt always starts with imagine. Then I do that, and yeah, so you actively have to tell it what you need to do, what you want to do. In the time we wait for this, we quickly go through Stable Diffusion, through Stability AI. Again, it's an open source tool. It has a lot of detailed tools. That's what you will see, by the way, the deeper you go in the rabbit hole. There is not one model by one company, but you usually can select between so many models, and each model is an experiment or has things that it does or does not. And you can see just the prompts that you get here. A Giant Bee with Endless Nightmare by Gerald Richter. I think all of the pictures look rather bad. So you have to do a lot of prompting, a lot of engineering to do that. The big advantage is it's open source. So you can download the entire model, you can run it locally on your device. If you're working with data that should be proprietary, then this is probably the tool you want to do. And it gives you so much freedom to do it exactly how you want. The downside to it is you need to get really good at prompting it so you can get what you want. However, if you say you are a designer and you want to be serious about this, then this is probably the tool you want to be using. Unless you're a designer on the Adobe tech stack, then Adobe and Getty got together and used their own tool, Adobe Firefly, which is great for some reasons. The first one is you have no liability reasons. All the training data was paid for and is accounted for. So whatever it creates, you can use openly. It's yours. You can use it for commercial purposes and for whatever you want. The downside is it's very expensive, as every Adobe product is, and it's the quality of the image generated is lower. Why is that? Of course, because every image generated in there is provided by Getty with a license, so that's a very limited set of data that it has. Let's quickly look at our diverse group of, yeah, but I think this goes a little bit more in what, still we only have men, but now at least diverse men. It's a step forward. Yeah. I actually like the first one. I think this is a cool comic. But this is exactly what we need to do a little bit more explicit in Midjourney, which again goes very much to the point that it gives me what I want to have. So again, I want to create a picture that I could have created at the Technical University of Munich, and for that I probably want to be it more man, because we are just the Technical University is still not as diverse as it should be in an ideal world, and I don't think if we have one single course where we have this degree of diversity at TUM. Unfortunately. At LMU, definitely, but here not so far. This is something we aspire to. Okay, but this was just a small experiment in the back. So choose your model based on what you want to have. If you're a beginner on a tight budget, or just want to make a quick experiments, go with DALL-E. If you want to get a little bit more serious, then go with Midjourney. It costs a little bit of money, but if you use it frequently, I resubscribed to it recently because I need a lot of visuals now. Actually, I did this on my account. I should do it on the Venture Lab account so you can also use it. Let me think about that. If you're really a designer and a techie, then use Stable Diffusion, make it your own, make the perfect control of the tools that you have. And if you're already on the Adobe tech stack and if you use it, so Firefly creates a little bit limited pictures, but what it's really, really good at is in adjusting pictures. So if you say, okay, I want to have another door in here, for example, if you make a picture of me here and you say I want a small door in the blackboard, it is quite good at doing this. So it works very well with the Adobe tech stack, of which I'm personally not a fan of, but I'm also not a designer. So for me, it's a little bit over the top. So I would probably go with Midjourney or DALL-E in my personal point of view, or mainstays where I'm. Was that a question?
Can you recommend one of these tools for different applications? Like, for example, if you want to have art, go rather in that direction. If you have really photorealistic stuff, in that direction.
I think Midjourney is the best for everything. So it's because you have the control. So let's say that picture in manga style. So let's try if it sees if we can do this in manga, and at the same time let's try to do this in Midjourney. So imagine manga style. As you can see, I just write it manga style. I have obviously no idea about mangas and stuff. But let's see what each of them do, and what hopefully we'll see that DALL-E again looks a little bit meshy in the middle. Actually, I think that's not too bad. It's very, if you just make too many, oh wow, and these look uncanny. So you have a lot of a lot of features that I didn't ask for. For example, those speed lines. I didn't ask for that it should have this zoom effect, this comical zoom effect. I did not ask for the lighting, and already both have again very similar lighting. They still don't never get rid of this blue tablet that we already had here. Maybe I asked for the same image, so maybe it did the same thing. Whereas here I have the feeling that the general quality of the artistic style is better in my eyes on all the 4 pictures. So, and this was just general manga style. Now I could of course go into one of the mangas that I like, or one of the comics that I like. So I think that Midjourney, if you're serious about what you want to do, is in any way the better choice. Of course.
Thank you very